All right, so this worked example is on the regression-based forecasting models. This is based on problem 13 of chapter 12 on page 544. And please open up the file P12_13. So once you open the file, it looks like this. So let's look at what the problem is. So the first problem is look at a time series plot. So that's what right here. Does it suggest a linear relationship or an exponential relationship? Well, I can say for myself that there's no way for me to tell just by looking at the data. Right? Maybe some people can, but I certainly can't. So the best way to do that is just to plot the data and see if we can see some kind of relationship from the actual scatter plot. So let's draw it like this. Okay, so I'm gonna select this whole set, and I'm gonna draw it, insert, and I'm gonna do a scatter plot like that. Okay, so once I have this, then so this is the GDP data. Um, then I can start drawing some trend lines and see if Excel will be able to tell me whether there's any type of relationship. So right click on any of the data point and say add trend line, and this is where I can change the trend line settings. So the first trend line I want to add is linear, and I want to add an equation. I want to change this color. So instead of using the blue, because all the dots are blue, then I'm going to change this to say red. Okay, so so the first one is red. So that's a linear trend line. Okay, so you can see that the linear trend line looks like this, and it doesn't really give a very good fit because the earlier years, all the forecasts are all the fitted values are lower, and then it becomes higher, and then it becomes lower again. So it doesn't look like a very good fit. Although you can definitely see a sort of linear trend, but a line doesn't seem like a very good fit. So let's try another. Uh, let's try another. Let's try another trend line. So this time I'm going to use exponential. So again, I'm going to add the equation, and then I'm going to change the color of the points to say green. I'm just going to change to green. Okay. Actually, it doesn't really help that much. But anyway, so this is the trend line. So this is a green trend line. So let me make this a little bigger. So you see that this is a green trend line like this, right? So you'll see that actually it fits pretty well because most of the time you don't see the trend line, which means that the trend line actually overlaps with the scatter plot. Of course, after this breakpoint, then you see exactly where the trend line is, right? Because there's some jumps around here. So it looks like exponential is a better fit than exponential is a better fit than the linear relationship. So when we try to come up with an analysis, maybe trying to come up with a forecast, maybe we should use the exponential model instead of the linear model. Okay, so that's our first investigation for the first part of the problem. So let's see what the second question is. So the second question is to use regression to estimate an exponential relationship between GDP and time, and of course you have to index time based on using an index instead of using the actual name of that quarter. And then let's do that. Okay, so first of all, let me add a column, and I'm going to call it period, and then I'm going to add period 1, 2, and so on, so I can actually add it all the way to the bottom. Okay, so now I can use the I can do a regression of GDP on period, and that will be the regression based on time series forecast. So in order to do that, I'm going to use stat tools. So I'm going to, I already called up stat tools. So I'm just going to go there, first declare the dataset manager. Say okay. So it sets this whole thing. And then I'm just going to do a regression. So I'm going to do a regression on this one. And then I'm going to use a derived variable because remember I have to, I'm doing the exponential um, exponential relationship, which means that I have to take a logarithm of the GDP. So I'm going to include the derived variable as the logarithm of the GDP. Okay. So then I'm going to use that as the dependent variable and the period as the independent variable. And I want to also have the show the equation, and also I wanted to draw the residual value versus the fitted value. Let me do the residual value versus the x value instead of the fitted value. Okay, so I'm gonna click OK, then see what I get here. Okay, so now you see that this is the result that I get. So the equation, so it looks like it's a very good fit. The R square is fairly large, so which means that the fit is really good. So this is this is the regression equation. So for every period, so meaning that from one period to another, the increase of the logarithm of the GDP is 0.0076. Okay, so that tells us that tells us that this looks like a very good linear regression and a very strong predictive power. The only thing is I want to see the scatter plot is that the arrow, the residuals actually starts to become very large after this period, right? So over time they're not random, but they're going up and down, which actually is a way to actually look at the business cycles because as you probably know from the economics class that the GDP, although it probably follows certain pattern of growth, but there's a business cycle that we go up and down. So you see that the residuals has a cyclical pattern to it. But after this year, then the residual drops way below and then suddenly jumps up to this. So there's some peculiarity at this break point, which actually turns out to be 2007, and that is this third question of this problem. That is that if we actually, instead of doing the regression over the whole period, over the whole data set, can we just stop at the 2007, see if we can come up with a better prediction or better forecasting model. So let's do that. So what I'm going to do is that I'm going to build another data set. So I'm going to copy this to here. Okay, but instead of keeping everything, I'm just going to delete everything, all the numbers beyond 2007. So I'm going to delete all that. Okay, and then I'm going to declare this as the second data set for stat tool. So I'm going to go to the data set manager and I'm going to declare this as a second data set. Okay, and then now I'm going to perform a regression on this second data set instead. So I'm going to do the regression, and then instead of using a first data set, I'm going to use a second data set. But the second data set, of course, I have to build the log of the GDP separately. So I'm going to add this one here too. Okay, so I'm going to select this one as that's the wrong one. Sorry, I'm going to delete this one. I'm going to delete this one. I'm going to, because I shouldn't use power, right? So it should be logarithm and then GDP. Okay, so I'm going to select this one as the dependent variable and the period as the independent variable. Let me check all the options that I have. Same here, good. Then I can click OK. And let's see if the regression turns out to be a little better. Well, the R-square certainly improved. It didn't improve by a lot because previously the R-square was very good already. So it's 99.3%. Now it actually increases to 99.7%. So that's a better. That certainly looks like a better explanation or explanatory power. The equation or the regression equation didn't change that much. So the slope changed a little bit. So it used to be 0.00763. Now it's 0.0076348 instead of 7335. So it didn't change that much. So the R-square didn't change much, although improved. The equation didn't change much. So what do we get? Well, the big difference, of course, is in the residual. So the regression over all periods that we have has this residual pattern like this. Because after this time, then you can see that the residual starts to swing wildly. But in the second regression, the residual actually stays within about good boundary. So which means that this data actually, if we only include all the way to 2007, this the regression is a better predictor, just to use that part. But that also means that if we only use the data from the starting point, which is let me see, the start from 1966 all the way to 2007, although we can have a better fit, but if we extrapolate this line or this exponential prediction to the future, to beyond 2007, then we will see the residual, or we'll see the arrows of prediction, much bigger arrows of prediction. So which means that although this is a pretty good fit up to 2007, but beyond 2007, this forecast doesn't really work very well. Well, this is a very common reasoning whenever we see a break point or a step function over time, when we in a data set. So when you plot out a data set, remember the first one that we did on the scatter plot, then you see that in 2007 there is a huge drop and then there's a huge jump, right? So that is a financial crisis that happens in 2008, 2009, and that totally changed the trajectory of the GDP. So you should not expect to be able to use the same forecast function for anything beyond that point. So maybe we have to do some particular treatment to make sure that when we include the data after 2007, then we can actually have a better fit using some other treatment.